Alright, so today we're starting our thermodynamics series, and we're starting off with a heat transfer problem. So, a 0.5 kilogram iron block is heated to 200 degrees Celsius and is dropped into a styrofoam cup containing 0.3 kilograms of water heated at 20 degrees Celsius. The system is insulated. This is a really important word. This pretty much means that the heat lost by the iron equals the heat gained by the water. Now, what does that mean? Since the block of iron is much hotter than the water, this means that the iron will try to reach the same temperature as the water, but then since the water is surrounded by an iron block, the water will also try to reach the same temperature as the block. So pretty much insulated just means that the heat lost by iron equals the heat gained by water. And we're given specific heat values, which this just means that the total energy that is released by heat. The iron at 450 joules per kilogram Celsius and water at 4,200 joules per kilogram Celsius. And the question is asking us to find the final equilibrium temperature and the heat lost by iron. So before we move on, we have to clarify the difference between heat and temperature. Heat is the transfer of thermal energy due to temperature difference, and temperature is just something that you can measure, or more specifically, the average kinetic energy of particles within a system. We have the heat equation here, which says that the heat lost by the iron equals the heat gained by the water, or just Q equals M, which is the mass, C, the specific heat value, times change in temperature. If we were to write out this equation in math, the heat lost by iron is going to be MC times the initial temperature minus the final temperature. And normally when we're looking at change in things, like change in time or change in whatever, right? It's normally the final minus the initial, but in this case, we're talking about heat, where heat is the amount of energy transfer. And now we can't have negative energy transfer, so that's why we have to put it as the initial minus the final, because the initial is obviously going to be much bigger than the final. Same thing for the water. The water temperature final has to go first because it's going to be more, because it's gaining temperature, so it's going to be more than the initial. And then this is just going to be the initial. So plugging in the numbers, the mass of the iron is 0.5 kilograms. The specific heat value of the iron is 450. And we have the initial temperature, which is 200 degrees Celsius, minus the final temperature, which we do not know. And here we go. The mass for the water is going to be 0.3 kilograms. The specific heat value is 4,200, and we don't know our final temperature, and our initial temperature is going to be 20 degrees Celsius. For this side, 0.5 times 450 is going to be 225 times the 200 degrees Celsius minus the final temperature. For this side, 0.3 times 4,200 is going to be 1,260. And then this side is going to be final temperature minus the initial temperature. Oh, and the final temperatures here on both sides are going to be the same variable and the same number, because we're looking for the equilibrium temperature, where both temperatures are the same. So in this case, the variables are the same. But to isolate just TF alone, we're just going to multiply 225 onto the parentheses and 1,260 into this parentheses as well. This side is going to get 45,000 minus 225 of the final temperature equals the 1,260 of the final temperature. This side is going to be minus 25,200. Isolate the final temperature variable, we're just going to add 225 of the final temperature to both sides, and then we're going to add 25,200 on both sides as well. This is going to cancel out, this is going to cancel out, and we're going to be left with 3,200 equals 1,485. Final temperature. To get to the final temperature, we're just going to divide 1,485 on both sides. We're going to get a final temperature value of 47.3 degrees Celsius. Finally, now to find the heat loss by iron, we're just going to use the same equation, Q equals mc change in T, where Q is the heat loss by iron. So Q equals the mass of iron, which is 0.5 kilograms, and the specific heat value of iron in this situation is 450 times the initial temperature, which is 200, minus the final temperature, which you got is 47.3 degrees Celsius, which is going to give us 34,364 joules, or 34.364 kilojoules. So let's test this out to see if our prediction stands true. So here we have our exact setup from before, and let's get the predictions on screen. We have the iron with a mass of 0.5 kilograms, a water with a mass of 0.3 kilograms, the initial iron temperature at 200 degrees Celsius, and the initial water temperature at 20 degrees Celsius. And let's just select start heat transfer, and we're going to see the final temperature, equilibrium temperature at the end. And yes, as you can see, the final temperature is 47.3 degrees Celsius as predicted. And yeah, that's the video.